Welcome to Ask and Learn.
Hi, the del G is free energy required to the generation of electrochemical gradient due to the transport of H plus ion or proton ions in the mitochondria is equals to the NFDM plus RT ln H plus inside the cell or inside the mitochondria or P side divided by the concentration of H plus outside the mitochondria means in uh, N side or in matrix space. So first we will calculate the first term, that is NFDM. So this is the membrane potential is given in the question. This is periodic constant and N is charge on ion, because here is proton, charge is transport side or outside the mitochondria. So N will be here plus 1 multiply by Faraday constant is given 96.5 kilojoule per volt, and the membrane potential is given 225 millivolt, or we can say that 96.5 kilojoule per volt multiply by 225 into 10 raised to power minus 3 volt, because 1 millivolt is equals to 10 to the power minus 3 volt. On solving this, we will get 21.71 kilojoule per volt. Now to calculate the second term, first we will have to calculate the concentration of H plus ion inside the mitochondrial cell and outside the mitochondrial cell. So the question, it is given that the pH value at P side, or we can say inside the membrane, is given 8. So from here the concentration of H plus ion is equals to 10 to the power minus 8 or 10 to the power minus pH. Now the pH at N side, or we can say outside the membrane in matrix space, is given 7. So the concentration of H plus becomes 10 to the power minus pH, that is minus 7. Now by putting the values here, we will get the second term for del G this way. So RT ln concentration of H plus P side divided by concentration of H plus at N side is equals to 8.314 joule per Kelvin per mole multiply by temperature is 298 Kelvin multiply by ln H plus is 10 to the power minus 8 divided by 10 to the power minus 7. Now on solving this term will give minus 2.302. So on solving this whole term, we will get minus 5703.37 joule per mole, or we can say minus 5.703 kilojoule per mole. So finally total del G will equals to the sum of minus 5.703 kilojoule per mole plus 21.71 kilojoule per mole. Now on solving this, we will get the final Gibbs free energy, that is 16.007 kilojoule per mole, which is required to create the potential gradient across the mitochondrial cell due to the transport of H plus ion. So I hope you found this solution useful. Thank you.